Okay, so let's take 7.3, section 7.3 notes on power functions and operations of functions. So we'll start by asking, what is a power function? So to us, a power function is going to look very similar to a polynomial. The difference here is that a polynomial has variables with whole number degrees. So the exponents are whole numbers, whereas a power function they can have variables with rational degrees. So rational exponents, meaning fractions. So let's do an example of each just so we can see the difference. So polynomial. So a polynomial, I should probably spell that right. Polynomial, here we go. We've been working with these for a while. Let's call this a function of x since we're dealing with functions in this section. So a function of x, let's call it, let's do x cubed plus 2x squared plus 4. That's a polynomial. Now let's look at a power function. So a power function, let's call it g of x, just so it doesn't have the same name. So g of x, let's say 3x to the 4/5 plus x to the 1/2. So that's a power function because this has rational degrees, so rational exponents. So a power function, a polynomial can be a power function, but not all power functions are polynomials. So this red function here, g of x, this is just a power function. But if you remember, whole numbers are technically also rational because you can write them as like 3/1, 2/1. So all polynomials are power functions as well as polynomials, but not all power functions are polynomials, if that makes sense. So what we're going to really focus on are operations of power functions. So what we're basically saying here, these are the four we're looking at: addition, subtraction, multiplication, division. So obviously we know what all of those mean. So we're just saying here that to come up with a new function h of x, you are allowed to do all of these four operations. So to add them, you just add them. To subtract them, you just subtract them. To multiply, you just multiply. And division is just division. So that's just something we have to say. We're not going to dwell on that too much because we already know what those four things are. But let's just jump into an example. So we want to find the sum and the difference of the following functions here. So let's start with sum. So sum, of course, means addition. So let's call our new function that we're going to find h of x. So since we're doing addition, that's going to be f of x plus g of x, which is 2x to the 1/2 plus negative 6x to the 1/2. So of course, plus a negative means we can rewrite it as minus 6x to the 1/2. And since these both have the same variable part, that means they're like terms. We have x to the 1/2 and x to the 1/2. They're like terms, which means we can combine them. So that means we combine the coefficients. So 2 minus 6 is negative 4. And then we have x to the 1/2. And that's our new function that we found by finding the sum of those two.